Chapter 3: AI as Key Exponential Technology in the Smart Technology Era. Part 2: Assisted, Augmented, and Autonomous AI. The question on the minds of many people is, how do humans relate to the AI algorithms and their outcomes? How are we involved? How are we benefiting? What is required of us? With its many differing algorithms, approaches, and applications, we can see AI in three main ways in relation to human intelligence and interaction. This is what is sometimes known as the man-machine intelligence continuum and is divided into three main categories or models: assisted intelligence, augmented intelligence, and autonomous intelligence. Assisted intelligence is considered as the most basic level of AI, where it is primarily used as a means of automating simple processes and tasks by harnessing the combined power of big data, cloud, and data science to aid in decision-making. It is also used most often in software systems such as robotic process automation or machinery, where the nature of tasks does not change and tasks are automated to free people to perform more in-depth tasks and improve things that people, companies, and organizations are already doing. Although in software-based decision-making systems, assisted intelligence does require constant human input and intervention with clearly defined inputs and outputs, with final decisions left in the hands of the end users. The assisted intelligence via machines tends to be where the machines are doing the automated work, which is typically repeated on a kind of continuous loop and learning from their internal systems. The machine learns based on its tasks, their most efficient processes, and responding to malfunctions, discrepancies, or anomalies. Examples of where we would find assisted intelligence in machines are industrial machinery, boilers, ovens, and manufacturing processes in factories. Augmented intelligence can be seen as a next level of AI that involves a symbiotic relationship between humans and machines, where this category of intelligence allows people, companies, and organizations to do things they could not otherwise do by supporting human decisions, allowing better and faster decisions, and is especially helpful in time-sensitive applications. Here the nature of the task changes as often as humans who are informing or training the machines require. In turn, the machine informs the humans based on its learnings, where existing data and information are combined to suggest new solutions. So examples include machine learning-driven image recognition, natural language processing, business intelligence, business strategy analysis, and decision verification and support. Autonomous intelligence represents a more advanced form of AI and involves processes where humans have taught the machine how to learn and adapt to new data. Here we also see the nature of tasks change, but also that decisions are automated and adaptation happens as the machine learns. Processes are automated to generate the intelligence that allows bots, systems, and machines to act on their own, independent of human intervention. Whereas there are many applications where autonomous intelligence can be used successfully, such as smart investment or autonomous vehicles, autonomy should typically be given within strict lines of accountability. Autonomous intelligence is also not a good fit for all applications, especially ones where it is difficult to quantify the best outcome, where more qualitative, intangible factors must be considered, or where it is better for humans to retain the responsibility of decision-making and have the AI functioning in a smart advisor capacity. These different application categories of intelligence are used in isolation and together. The truth is, human intervention is required, whether or not a human is required in every step of the process or not. Humans will need to verify findings, interrogate learning paths, and check the efficacy or validity of the machine learning process and subsequent results. In order to understand the different ways in which machine learning is applied to everyday processes, improving existing processes, and create altogether new processes, let's first look at what Kai-Fu Lee calls the 4 waves of AI. Artificial intelligence, as we imagine it in its future state, has not and will not hit us all at once. Most likely it will happen in 4 waves that will lead up to a completely revolutionized world, far more powerful and distant than the experience those of us old enough to remember dial-up internets and a time before mobile phones. These waves, harnessing AI in different ways, include Internet AI, business AI, perception AI, and autonomous AI. It does not mean that these waves will happen separately, and we do not know how long each one will take to reach its apex. But we do know that Internet AI and business AI are already well on their way, and perception AI is following closely behind. Already the digital and business world are using AI in their intelligence, targeting and automated learning, and AI's perception skills in recognizing images and speech are growing too. Autonomous AI might not be a part of our lives as yet, but great progress is being made in the world of driverless cars and drones and more. Internet AI is something every person who has searched Google, watched Netflix, been on Facebook, and watched YouTube has experienced. It is the way in which your media consumption builds up information on you and uses that information to recommend things based on your search, browsing, watching, buying, or reading history. It is the algorithm behind targeting and personalizing your online experiences. It does more than merely pick up what you watched, for example. It knows if you watch to the end, and in that understand that the title may have interested you, but the content did not, or the length was too much for your attention span. Because of the huge amounts of data constantly building up, with new things to consume online and more people interacting with them, it is now also possible to tell the difference between real and fake news and what titles are likely to generate more reads or watches, so as to continually optimize the ways humans judge books by their covers. Whereas high-tech organizations such as Google and Facebook, both American, Tencent and Alibaba, both Chinese, and others have remained at the center of the first wave, the second wave allows non-high-tech based organizations across multiple industries to generate intelligence, efficiency, and optimization from their own data. This leads us to the second wave of AI, business AI. Business AI relies on the huge amounts of historical data that businesses have been naturally capturing with every action and transaction. The ability to digitize, verify, and remove any duplicates or incorrect entries results in the ability to be able to use this data for intelligence. This is why the first instance of business AI is to clean and mine the data in a way that is ready for the algorithms that rely on data to predict, measure, analyze, conclude, personalize, and recommend. Business AI finds hidden correlations and learns from past decisions and outcomes within the organization. Business AI accounts for but looks much deeper than seemingly obvious correlations or ways humans have traditionally predicted outcomes. These algorithms look for and find things that we would otherwise miss, like instances that might appear unrelated in isolation. Of course, this is made possible by big data and our abilities to compare, analyze, and check data against huge amounts of other data. In the case of medicine, the more data we have on past cases, diagnosis, and cures, and the more we combine this data, every doctor with this technology is then enabled with the information of the hundreds of thousands before her, millions of cases and information from every medical publication, and is thus empowered to be more adept, astute, and knowledgeable at her job. The result? Money, time, and lives are saved. Perception AI is related to the way in which machines are now able to interpret and make sense of images and audio, to see them, perceive them, and even make sense of them in the way that used to be true to only humans. This means that images, objects, and sounds are now data, able to be analyzed by AI algorithms. This is all very helpful with the introduction of driverless cars. More on this when we talk about the next wave, that are able to make sense of the world around them by creating a digital duplicate or twin that can be perceived and analyzed. It is also a breakthrough in intelligent shopping and education that can now be customized to suit each individual need through machine perception and understanding of our responses. Autonomous AI is the result of a combination of the powers the first three AI waves bring us. This culmination will allow machines to not only respond automatically, but will allow them to adjust and adapt to new instances and environments. In the world of robots that have automated a large portion of production already, this automation will reach new levels of intelligence where machines will make decisions for themselves based on being able to analyze and respond to changing circumstances. Machines will have the power of sight, sense, touch, reasoning, and analysis. The combination that truly allows things such as autonomous vehicles to operate in changing, fast-paced environments. As the four waves emerge with new power and force, and as a multitude of smart technologies and algorithms join forces, we are steered towards a machine-human future where the machine aspect will become such a natural part of our existence, simplifying our lives with intelligent convenience and insights. We can really begin to be excited about how our lives could change for the better. Although I have dedicated a few chapters to AI applications across multiple industries, I will briefly highlight how machine intelligence is already being applied. As it is now, AI's applications to problem solving in business, governing, and society are endless. Some experts believe that cognitive computing represents our best, perhaps our only chance to tackle some of the most enduring systemic issues facing our planet, from understanding climate change to identifying risk in our increasingly complex economy. The capabilities enabled through machine intelligence will force businesses and governments to rethink their operating models, and leaders, unions, and institutions to rethink the social, political, and economic theories upon which they are founded and built. While some processes may be refined, others will need to be reinvented, and still others built from scratch. Reimagining our world is not a future state, it is now. New skills, training, and education are necessary to frame, process, and adjust to a new world order that comes with machine intelligence and its countless applications. To begin with, a decision about which challenges to present to our cognitive systems and applications needs to consider how we prioritize our problems. Which do we solve first? Which are most appropriate, just, and will yield the best outcomes for the highest number of people? If we are not thinking about this, then we must ask ourselves if we are best using the tools of the smart technology era, and if how we are using them is based on our intentions for the future that is in our hands to create. Applying AI to our challenges is manifesting new ways of thinking, working, and collaborating, and will invariably lead to cultural and organizational change, some of which may be challenging. This is a topic we discuss in detail later in this book. Cognitive computing systems have obvious benefits in the fields of medicine, finance, law, and education, and obvious ways to optimize service delivery and improve inclusion, governance, and politics. These systems can also be applied in other areas of business, including consumer behavior analysis, customer support bots, personal shopping bots, tutors, travel agents, security, and diagnostics. They are the result of intelligent, advisory, and cognitively enabled solutions that are interacting with data to learn, improve, and expand. Some of this data is existing and some is reliant on constant human interaction, the humans using the systems. Cognitive applications typically revolve around text and rich media, or customer interactions for analytics, tagging, searching, machine learning, categorizing, clustering, hypothesis generation, question answering, visualization, filtering, alerting, and navigation. Computers are trained using extremely large historical datasets to help them adapt and learn from prior experience, identify anomalous patterns in large datasets, and improve predictive analysis. Across the spectrum of analytics, we have descriptive and diagnostic analytics that provide information and hindsight, diagnostic and discovery analytics that provide diagnostics and insight, predictive and prescriptive analytics that provide foresight, prognostics, and optimization, and cognitive analytics. Descriptive analytics asks what happened, describes historical data, and helps to understand how things are going. Diagnostic analytics asks why it happened, helps to understand unique drivers, segments data, and performs statistical and sensitivity analysis. Discovery analytics asks what is hidden in the data, helps to discover underlying patterns, and visualize and detect clusters in the data. Predictive analytics asks what could happen and forecasts future performance, events, and results. Prescriptive analytics asks how to make it happen and provide analysis that suggests a prescribed action. Cognitive analytics asks what to do, why and how, and provides proactive action, learning at scale, reasoning with purpose, and natural human interaction. While the applications of AI are changing, adapting, and merging with other technologies continually, there are some common technical uses of AI in place today. Predictive analytics occur when data on a business, customer behavior, employee tendencies, and even news or economic influencers are consumed, understood, and analyzed for trends to predict future behavior and provide insights on how to capitalize on that behavior or change processes or directions to benefit from it. Static image recognition applications recognize and know what images are and can tag them and classify them in context, as it has information about the contents of the image. Whenever the algorithm is fed a new image, it can recognize, classify, and tag it. Natural language processing allows computers to understand and interpret language the way it is naturally spoken by humans. It can process languages to answer questions and translate to other languages in real time. It keeps learning from itself, and every interaction trains the algorithm to be more accurate and pick up on new languages, dialects, and pronunciations with ease. With natural language generation, computers can develop an understanding of the data presented and turn it into written text. Processing of patient data at scale allows for a full view of patient data with continued understanding to make patient care more effective, personalized, and holistic. This can reduce the chances of misdiagnosis, impersonal treatments, or treating symptoms rather than causes. It also allows us to learn from every past case to save huge amounts of time in diagnosis and treatment. Object detection and classification applications go deeper than simply identifying digital images and are enabled to identify and classify objects in the real world. These AI applications can pick up information like how big the object is, how far away it is, and even how it might behave based on previous experiences with such an object. Robotic process automation has automated entire processes, tasks, workflows, and functions through mimicking and learning from existing processes, whilst constantly improving based on new learnings. It can be used internally or as customer-facing applications as well. Deep learning increasingly addresses a range of computing tasks where programming explicit algorithms is infeasible. These are domains like fraud detection, robo-advisors, smart trading, recommendation pipelines, fully automated call centers, inventory, and product review auditing. Deep learning is also extensively used in search, autonomous drones, robot navigation systems, self-driving cars, and robotics in fulfillment centers. It is applied in many areas of AI such as text and speech recognition, image recognition, and natural language processing. AI systems can now recognize objects in images and video and transcribe speech to text better than humans can. Google replaced Google Translate's architecture with neural networks, and now machine translation is also closing in on human performance. Machine learning techniques applied to satellite imagery can also predict crop yield better than traditional techniques used by the US Department of Agriculture. Artificial intelligence is also making its way into the realm of modern healthcare. Google DeepMind is revolutionizing eye care in the United Kingdom, and IBM's Watson is tackling cancer diagnostics on par with human physicians. Both AI systems use deep learning, which is particularly applicable in diagnostics. Stanford researchers also created a deep learning algorithm that could boost drug development by using a type of one-shot learning that works off small amounts of data for drug discovery and chemistry research. We already have many use cases for deep learning in the categories of sound, time series, text, image, and video as it pertains to various industries. Sound use cases include, for example, voice recognition for user interface, automotive, security, and IoT applications, voice search for handset makers and telecommunications, sentiment analysis for customer relationship management applications, flaw detection such as engine noise in automotive and aviation applications, and fraud detection for hidden audio artifacts in finance and credit card applications. Time series use cases include, for example, log analysis and risk detection for data centers, security, and finance applications, enterprise resource planning for manufacturing, automotive, and supply chain applications, predictive analysis using sensor data for IoT, smart home, and hardware manufacturing, business and economic analytics for finance, accounting, and government applications, and recommendation engines for e-commerce, media, and social networks. Text use cases include, for example, sentiment analysis for customer relationship management, social media, and reputation management, augmented search and theme detection in finance applications, threat detection for social media and government applications, and fraud detection for insurance and finance applications. Image use cases include, for example, facial recognition, image search for social media, machine vision for automotive and aviation applications, and photo clustering for telecommunications and handset makers. Video use cases include, for example, motion detection for gaming and user interfaces, and real-time threat detection for security and airports. We do not believe that we have yet seen the full capacity of what we can expect from AI and its applications, but we have certainly seen its applications evolve within themselves and into other applications. The AI process can be best understood as an evolution of analytics, where each part of the process and evolution is integral for intelligent results. This analytics process, in most cases, starts with data, but data is involved in every step after that and can never actually be separated from the process. The evolution part is how we see that data, what we do with it, how we learn from it, and where we go next. With all of what we can already do now, imagine we fuse it with any internet-enabled device, a drone, a remote, a robot, a car, a sensor, or a heavy industrial machine. This is where we see cognitive computing unlocking its true value by inserting intelligence into and learning from the physical world.